So this is the security track. Our track moderator is going to be John Kristoff.
Thank you, Jeff. Of all the introductions, that's certainly the most recent. If I could, the folks that are on this list, if you are here, I hope that all of you are. I've seen a couple of you, so just make yourselves known to me. You can sit up in the front. We're going to try to get through this in an orderly fashion. Those of you who have attended a security track at NANOG before, there's something new that's happening this time that I don't think has happened before, although we tried to have it done at a previous NANOG, it just didn't work out. This will be webcast. From days gone by, since the very first security track that Barry had done many years ago, it was a little bit of a secret handshake club, and I think those days are unnecessary now. What we have to talk in here is not so secret anymore. So this will be webcast. If that bothers you, simply don't come up in front of the camera or go up to the mic, but I think by and large most of you will be okay with that. We have a few people who come up and do a talk. I have something that if there's time permitting I'll do at the end. So I'm just going to go ahead and get started and let each person introduce themselves. So if you'd like to come up, Jelena, we'll get started without delay. So if we could have Jelena's talk up on the screen, that would be excellent. There you go. So you just
Thanks.
Green to go forward.
Yeah, thank you. So my name is Jelena Mirković. I work for USC Information Sciences Institute, and I talked at NANOG 64 about our research solution to DDoS and BGP prefix hijacking called SENSE. And I just wanted to briefly talk about this again. It's now ready for deployment, and we're looking for interested networks to try it out. Our solution is called SENSE, which stands for Security Service for the Internet, and this is joint work between me and Minlan Yu at USC, Ying Zhang at HP Labs, and Shivram Ramanathan at USC as well. So today's attack mitigation for DDoS and BGP prefix hijacking mostly focuses on the victim paying for defense, sometimes very high price, and the victim pretty much pays to withstand the attacks, to make itself more robust against attacks. In DDoS realm, we have two flavors of operational defenses. One is to buy a local device that will sit at victim's network and profile traffic and come up with filtering rules when the attack happens. And that works great if the attack is not very heavy. If there is high volume of attack, then nothing that you do at the victim helps. You have to go further upstream. Then you go to cloud-based defense, and the cloud-based defense geo-replicates the victim's resources, and sometimes it also applies packet scrubbing at the packet inspection to, again, profile traffic and figure out what should be filtered. And this is, infrastructure-wise, this is pretty costly solution because the cloud needs to deploy resources geographically in many regions, and the deep packet inspection and packet scrubbing to be done at very high packet rates. This requires a lot of costly equipment, and this cost is passed on to the victim. So the victim pretty much pays to withstand the attacks. In BGP prefix hijacking, there is BGP Anycast that is deployed that pretty much, again, advertises victim prefixes in many geographical regions and makes it harder for the prefix to be hijacked. But then the victim's traffic needs to either be serviced at these regions or tunneled back to the victim. Again, there is a heavy infrastructure price. And if you could do this on demand, you could do this to prevent the attacks. Either ways, it's pretty costly. So our solution means to complement this space of solutions by offering to victims something that you can do on demand. You can do this with current ISPs, with current ISP infrastructure, and you can ask for ISPs to help you in observing your traffic, your inbound traffic, or observing routes to your prefixes. And you can also ask for filtering some of your inbound traffic by specifying a network header level signature. or you can ask to demote a route that you believe contains a hijacker. This solution has two pieces. There's a server that sits at the ISPs, and there's a client that sits at the victim that makes the requests, and the communication is secured, and it's robust also to misbehavior, both of the ISP and at the victim side. The main feature of this solution is that it works with current ISP infrastructure. You don't have to buy new equipment. It won't be as accurate as cloud-based defenses in some specific cases of attacks, but in many attacks, it should be as effective and it should be less costly. For ISPs, there is no infrastructure cost to deploy. If they want to charge the victim something per request, our guess is that the charge would be way less than for clouds because there is no infrastructure cost for the ISPs. So this is how Sense works. ISPs run Sense servers. Victim identifies ISPs to which it wants to talk during the attack. It could do this based on its own knowledge of the network of the inbound traffic paths, or it could do this using a public Sense directory. It sends queries to those Sense servers. The Sense servers reply back with some information. The victim, all the intelligence about the attack mitigation resides at the victim. So the victim looks at these reports, figures out what it wants to do, and then again sends requests to the servers to implement either traffic filtering or route demote. These are the Sense APIs that would be exported by ISPs. Again, they're very simple. Sense server is implemented as a web service, and we leverage the existing functionalities for web services such as robustness, security through HTTPS, and you can charge for this service. You can charge the victims by coupling this with e-commerce solutions. So you can ask for traffic queries. You can ask for some traffic to be filtered or allowed. You can ask for what's your best route to my prefixes, or you can ask the ISP to demote some routes. In all these cases, the ISP can decide whether to fulfill this request or whether to reject it if it goes against its policies. The only case where it might go against its policies is if you ask to demote a route that the ISP has to your prefix. The route that is remaining is maybe more costly. You could, as an ISP, choose to reject such a request, or you could pass the cost on to the victim. These messages that you get from the victims need to be authenticated, and the only authentication you really need is that the victim is authorized to speak for a given prefix. And this authentication can happen in multiple ways. If the victim is direct customer of an ISP, then the ISP can build a database that binds the public keys of the machines that are allowed to speak for a given prefix with the prefixes. If the victim is a remote customer, so the beauty of the Sense is that you can use it both for your direct customers and for remote customers. If the victim is a remote customer, we can use RPKI to authenticate the ownership of the prefix. And if the victim is under such a heavy attack that it cannot communicate anymore, the victim can delegate a proxy in another network, and the proxy can run the same algorithms. So pretty much what resides at the victim are algorithms that figure out what to do based on reports. The same kind of algorithms can be offloaded to a proxy in a cloud. All that the victim needs to do is offload these algorithms and generate a certificate that now passes the ownership of the prefix from the victim to the proxy. These are just a few examples how Sense would work in isolated deployment. So in isolated deployment, the A is the ISP that deploys the Sense server, and V is the victim that is under attack. The blue is the legitimate traffic, the red is the attack, and right now, this is the simple solution that ISPs deploy in a lot of cases, which is figure out where the heavy traffic comes from when someone is under attack and just black hole this traffic. Sense automates this process. So the victim would ask the ISP about the traffic query, where is my traffic coming from? The ISP replies by giving the counts of packets or bytes on each incoming link. So the victim would learn that the link F to A carries a lot of traffic now. And so the victim might decide that I want filtering on this link. It would set the traffic filter request to the ISP to filter on the A to F link. And again, this automates the process that currently exists at ISPs, but note that this time victim has a say what to do. So the victim might have intelligence that the ISP doesn't have about its inbound traffic patterns, about its operations, the business model, and so it may make better decision what to filter and where. The bottom example is the case of reflector attack, and for reflector attack, the problem is that the victim is getting a lot of responses. Some of these might be for legitimate queries that it sent, and some of these may be the attack, and it's very hard to filter out these responses on case-by-case basis if you're not seeing both directions of the traffic, because you cannot store the state for each request to match it with the response to know that the response is legitimate. Our solution to this is pretty simple. The victim nets all its outgoing request traffic, and it chooses the range of ports to do the netting, and then it sends to its ISP that is deploying sends a traffic filter and a traffic allow message. Traffic allow message says allow everything for this service going to the net IP, going to those source ports that I'm using for netting, and the traffic filter says drop everything else, all the other responses for the service that is misused for the attack. Of course, the sense, when we developed sense, we assumed that the victim might have enough intelligence to decide what's best for the mitigation. In some cases, the victim might not have that intelligence or might not have technical knowledge. They want to offload everything to the ISP. Sense can also be just an ISP-only solution. It's just that the ISP now runs both the client and the server. And so how can it help in this case? It simply automates what you already do today manually. So in the case of the Sense client running at the ISP as well as Sense server, the client would collect periodically traffic information from all the links, profile this for each of the destinations, figure out when the destination is under attack, and then come up with the filter suggestion rules that could then be communicated to the Sense server as messages. So there are three components of Sense. I talked to you about two of them so far. There is Sense server that sits at ISPs, and all it is a web application plus some scripts that communicate with routers. There is the Sense client that can sit at the victim, or it can sit at ISP if the victim does not have technical knowledge. And it's an application that sends messages to Sense servers, analyzes responses, and decides on the mitigation strategy. How does it decide? We have several algorithms that are pretty simple that they are generic, they will work for most victims. And the decision process is coupled with the attack detection module that will detect the attacks either at victim or at ISP. That's the third part of Sense. It can work on net flow records, it can work on PCAPs, it analyzes the traffic, figures out when there's an attack, and alerts exports the filters that are suggested. If the victim has another detection and mitigation solution that detects the attacks and profiles traffic and suggests filters, victim can use that instead of our attack detection module. And the only time when that would be, the time when this would be useful to the victim, when Sense would be an add-on service to this local attack mitigation, is when the victim is under heavy load and it needs help of its upstream ISP. So instead of picking up the phone and calling up your ISP, you could hook your local defense detection and filtering module with Sense client, and when it cannot handle the attack, it can communicate with the client, which are the filtering rules for the ISP to deploy. What Sense can do for ISPs, as I said, it automates the process that is today highly manual, and it can help detect and diagnose attacks. Some ISPs have sophisticated solutions, others are still doing this manually and have in-house solutions, so it can complement these. And this is an add-on service that the ISP could sell to its customers. The way that Sense can be integrated with an ISP, the server is a web application which can be run on any web server within your ISP. And we've put a two-factor authentication on the admin account. We can use database for prefix ownership proof, or you can use RPKI, that's all functional. And then you would supply IP addresses of the switches and how to authenticate between the server and the switches so that the server can talk to the switches and get traffic reports or put in rules. For traffic observation, if you have SDN, we use SDN, that works great. If you don't, we can use the SNMP to collect traffic observation. For traffic filtering, we can use SDN, flow spec, or access control lists. For route observation and filtering, we can interact with the router software. Right now, we have integrated support for Quagga. So we've tested Sense extensively in our lab in simulation and emulation. Emulation tests included testbed experimentation where we replicated topologies of hundreds of switches and talked to them to check how many concurrent requests we can serve and how long it would take. And so we had good performance. We generally have one rule per Sense message, so this does not eat rule space at the switches. Whatever we do is done by engaging functionalities that routers do on the fast path. So this should not introduce any slowdown. It's easy deployment. There's no separate hardware that you need. And we scale with the number of the concurrent requests and the number of switches, not with the volume of the traffic or the number of attackers. So that no matter how large the attack, we will scale accordingly. So the reason why I'm talking to you today is that we have a prototype. We've tested it in our lab. We're pretty happy. We've talked to a few networks. They all were very interested, but this is a slow process. It takes a while for anyone to deploy this, and I'd like to see if there is anyone interested here to learn more. You could come talk to me. I'm going to leave a few handouts here on the front row about Sense. You can visit our webpage. You can email me. And we can explore possibilities. If you're not ready, you can test drive this in the TER lab, which is the testbed that we used to see how it works. Or if you're ready, you can simply feed Sense some of your traffic and see if it detects attacks and which filters it suggests. And then if you feel confident at some point, you can go a step further and implement it. Thank you. So any questions?
This is John Christoph, DePaul University. I guess maybe the question is more for the audience. I assume you don't have it's in production for any ISPs yet. So, and I'm certainly not trying to embarrass you. I'm literally trying to encourage you. My question is to everyone is, if you wouldn't do this, what would it take for you to implement it? Or alternatively, why wouldn't you? And I assume for some of you, maybe a trust issue, but if you could elaborate, I'd be curious to hear what it takes for people to implement this kind of technology.
So, sorry, say that again. I missed the main part of the question. So it was like, why wouldn't someone do this, or?
Right, so it's not so much a question for you specifically, it's a question for the audience.
Okay.
What would it take for you to implement this? And if you wouldn't, why wouldn't you?
Okay, thanks. Yeah, that would really help me as well.
Matt Pitak from Yahoo. I'll help answer your question partially there, John. You say that for gathering information, so someone can do a query on flow information. I saw your slide say you can use SNMP or SDN, and I'm kind of wondering, how do you get information about traffic flows to a given prefix via SNMP? Because I've never figured out a way of doing that. The SDN part sounds kind of interesting, but SDN is so vague that I'm not sure how I configure SDN route or flow export on my router. Do you have more information on kind of the mechanics of how this magic tell me where my flows are going happens.
Right. So pretty much what we need from the routers is net flow information, and it doesn't have to be per prefix at that point. You talk to the router, you get the net flows, and then at this aggregation point, which is the sense server, you can aggregate and filter and figure out how to communicate this to the customer. And so one reason why someone might not want to deploy this, what John asked, when we talked to people, there were some privacy issues raised, like, oh, I'm doing load balancing and I don't want people to learn about my load balancing. So there are ways that you can communicate to the customer, to the victim, that I'm sending 50% of traffic this way and 20% of traffic this way, and you can anonymize the links, so the links are only meaningful to you. It doesn't say I'm sending this to AT&T or to level 3, it just says I'm sending this to X and Y. But then when the victim comes back and says, I want filtering on X, you have a way to identify back which link this really is to put the filter on.
So to answer your question, John, this assumes that some of the really, really hard problems have already been solved. And once we solve those really hard problems, then bolting this on isn't so bad. But we've got to solve those really hard problems first.
Thanks. Any other questions? Yeah.
Doug Montgomery, was the ability to use RPKI to authenticate these messages part of what's shipping? And if so, how do you do that?
Sorry, is the RPKI's ability, so that is already in the code, and what's the other part of the question?
So you have some way of signing your messages with RPKI keying material, yeah? Mm-hmm. And so the sense node downloads, runs a validating cache, and brings down the public keys?
Yeah, so I'm not sure I completely follow, but let me see if I can reply, and you can tell me if that answered your question. So RPKI is not widely deployed in the validation space, right? So there are networks that deploy it at the origin to protect their origin, but the validation is not widely deployed. So what we hope is that this would go hand in hand with RPKI validation, and an ISP that is interested in deploying this would deploy validation as well. If they don't, then there are other ways that we can look into to validate the ownership of the prefix, but I think that, technically there is no problem there. There might be a cultural problem, but technically all you need is a cryptographic certificate that binds a public key and a prefix together, and we know how to do this. That's a solved problem for a number of years now.
Okay, that's in the
Right.
available prototype now.
Right.
Yeah, cool.
Vikas from Microsoft. So basically, this is assuming that the ISP will support this implementation, right? Because we are heavily dependent on the ISP side where the
Yes.
same server will be sitting, right? So in case if there are prefixes, which, let's say RPKI is not there. So what is the other source of validation? The customer has to give all of his prefixes to the ISP and list it. And what about if the customer is multi-homed and it has to, like both the ISPs are not supporting the different prefixes from the other side? So how will you solve that one?
So the customer, if it's a direct customer of an ISP, then they can communicate offline and store into the database that these are the prefixes that you own. This is your public key, and that public key is authorized to talk to the prefixes.
Yep. But what if there are multiple ISPs involved? Like if the customer has dual home ISPs and he doesn't have the RPKI, so how will they validate? Because one ISP can say that, okay, I'm not going to entertain this prefix through me.
I see. I'm not sure. That's a good question. I think that's a question that no one currently knows how to solve, right?
That's okay.
Yeah.
We'll see.
But it's a good question. I actually really hope that RPKI, takes off, because we see it taking off in a few places. So, yeah. Thanks. Whoops.
Thank you very much, Lena. That is a good question. That's a question that I had to face too with a very simpler project. If I have time, I'll talk a little bit about it towards the end. So our next presentation is from a student, which I think is maybe perhaps a first for this track. It just so happens to be a student of mine, but now a colleague. Brian Haley is going Give us a little bit of a view from that part of the world and what he is involved in security competitions, and specifically networking challenges in the competitions that he participates in. So Ryan, if you would, there's actually there's a mic over here.
Oh, is there? Oh, this isn't too bad. Hello, good to go? I got one. All right, hi everyone. Yep, good. So my name's Ryan Haley. I'm from DePaul University. I earned my Bachelor's of Science in Information Assurance and Security Engineering. At DePaul University, we're a highly network security focused school. So a lot of my education has been, straight up networking with a little bit of security tied in. So I have kind of both sides of the coin. I'm currently working on my Master's in Computer Information Network Security, and I'm a research assistant at DePaul University. So today I'm going to talk about a few of the challenges, computer security challenges I've competed in over my time, 3 specifically, just to give you guys an idea of, kind of my upbringing and, how I've learned going through my education. And I want to kind of encourage you guys, if you have any ideas, to reach out to me and how we can incorporate new challenges in the future to future students. So first competition I ever did, Cisco NetWriters. Pretty simple. You get a list of 100 questions. If you've ever taken a Cisco test, it's pretty much the exact same thing. Problem with this is it's, Cisco test kind of vague. Don't know what the, maybe the exact answer is. And, for a freshman in college, it's not really that interesting. I mean, it's good for foundations, but at some point, you got to do a little bit better. Second competition is called the National Cyber League. So this is a fairly new competition. This started about 4 years ago. The first competition I was in was their first iteration of it. And they did a kind of a red versus blue team aspect. They switched from that, and now it's Jeopardy style. So you can sign up anywhere in the world. You log in, you get a list of all your questions, and it's Jeopardy style. So maybe a topic is forensics, maybe a topic is log analysis, 100, 200, 400 points, et cetera, down the line. So of course my favorite is network traffic analysis. Sure, everybody's used Wireshark before, and some of the more simple ones are, as on the right, you probably have a hard time seeing it, but this is a wireless capture. So you have to use Linux tools, crack the password, decode the packets, and it'll ask you certain questions. Oops, I guess I don't have them there. But it'll ask you questions like, what was the attacker's IP, and what's the MAC address of the wireless router, and what's the vendor of the wireless router. So it gets students really immersed in looking at PCAPs and digging in there and trying to figure out what's actually going on in their network. So this year they stepped it up a little bit with a challenge such as this one. So this challenge was to actually kind of reverse engineer a custom protocol they made. So I had a lot of fun with this. So they gave us a PCAP, looked like this, full of, 10,000 packets or something. And after digging through it, there's only about 20 packets that really matter. So once you find those, it's actually fairly simple. So the only part that really matters is the last 4 bytes of this transaction. So these 4 bytes change back and forth. So eventually I had to figure out, going from client to server, what each bit means, each change, and what the responses mean. And then they ask you questions, how many encrypt requests were made, and it's in the question. They describe it a little bit better. But this was another step for me in my learning process. How do I actually look at a protocol I have no knowledge of and figure out what's going on? So the third competition is called the Collegiate Cyber Defense Competition, and this is where I've learned so much. So this competition is red versus blue. Students are the blue team, so blue teams are defenders, red teams are attackers. 8 of us on a team, and we get a network such as this. It's a small network, but you get, you get a few servers, a few users, and you get some network equipment. Since I've started, I've always been the network guy. I love it. So this year we had a switch, a router, and a firewall. Luckily, this year was a Palo Alto firewall. So each year, the vendors may change, so that's forced me over time to learn quickly, how to adapt to changes. What's interesting about this competition is they don't usually tell you what's going to happen beforehand. So, you're walking in a room, you could get, a Juniper, a pfSense firewall. I mean, you have no idea. And, I have to kind of adapt like that. And it's good and bad in some ways. Other students at other schools, if they don't have, familiarity or they don't have the ability to go out and obviously test a Palo Alto firewall, then, it's kind of, that's not good for them. But at the same time, it helps students to think on their feet and adapt quickly. So my first iteration of this competition, it was simple things like this. So we had a Cisco switch, and I'd go through Cisco guides and just block pretty much everything. I'm thinking, okay, there's the attackers. I'm going to stop everything conceivably possible that could possibly happen. And really, in the end, the only one that matters here is turning off your switchboards, because attackers think, they put the fear in you, right? But in these competitions, they don't have time to go through and do anything advanced. If you turn off your ports, you can't really do anything. So next iteration of this, they got smarter. So this is a Cisco config I found on one of my routers. So this is pretty cool. What they did was they started to hide their commands in there. So they'd backdoor it, kind of, and they'd use these applets to hide their configs. They'd have an SNMP server set up with a username, so they could just remotely change commands, and I couldn't see it. Show run would not show it. Show users would not show it. Seeing who's on the router wouldn't show anything. So what you had to do to find this was you actually had to export the flash off to a box, and that would actually show all the hidden commands they have. So they were getting sneakier, but you're still able to find it. And then finally, this last year, the most interesting one I had was we had, like I said, the Palo Alto firewall. And this was a 2-day competition. And on the second day, they kept getting in, and I could not figure out why for the life of me. And eventually, I'm logging in, and they keep booting me out, and I log in, and finally a message pops up and says, if you can see it, hello from Red Team. And I'm sitting there thinking, how can they do this? And it turns out, I talked to them afterwards, they actually used an exploit to get a bash shell on my Palo Alto firewall. So how do you defend against someone that has root access on a device that you don't even have? So I learned from that, and after that, I blocked access to management ports and everything else, and only allowed access through the firewall. And after that, they can't really do anything. So that's kind of the challenges I've been through, and like I said, there's benefits and drawbacks to all of them, and I kind of want to reach out to you guys because I want to create a new competition in the fall, and specifically on network security side. I mean, that was a light introduction of what I've been through, but that's really all that students are exposed to as far as network security, and it's seriously lacking. And I've been around in different security events and things, and it's a lot of reverse engineering and it's a lot of other things, but network security is often overlooked. So if you have any ideas on how to reach out to the next generation and help bring them in, I'm all ears. Thank you.
Matt Pitak, Yahoo, I kind of hate to rain on your parade, but you're already doing far more there than 90% of the people out there in enterprises. I dare say if you're looking around saying, oh my gosh, okay, I'm ready to take it to the next level, this was my intro course, fully half the companies here are looking at that going, oh, shit, that's some good stuff we should be thinking about, isn't it?
So,
You're already at the next level. Congratulations.
yeah, I agree with that. No, and that's the problem. So, you know, all the companies are trying to bring in young talent, right? And I see that coming from both sides, because, you know, I'm now a grad student and entering the workforce and things like that. And I interview all these companies, say we have shortages, we can't get enough people, and yada, yada, yada down the line. So looking back from my side, you know, why are these students not learning the material? Well, some, you know, they go in class and it's all theory and this and that, and that's kind of what I want to talk about, these kind of events. And I don't think really there's enough of them. There's not really, you know, really good ones out there. This CCDC competition, I've learned so much from this, but unfortunately, it's once a year. And if it's a one and done competition. If you don't win, you don't move on. So there's so many students that, you know, participate for a day and that's all they get. There has to be, you know, there has to be more to help them bring them up to speed and get, you know, you guys interested in hiring them. And there's just
So
not the
seems
support
stuff,
behind
just
it.
more of it is really what you're looking for.
Yep.
Gotcha. Okay.
Tim Averill, Akamai. Hi from the Red Team.
Hi.
I've been on the CCDC Red Team 4 years in a row now.
Okay.
And for anyone in the room, if you're looking to hire someone who has network security clue, I would strongly recommend going to CCDC, because you can usually find someone that's looking for a job or an internship and get them in and teach them how a network really works, especially when they're not being attacked by us.
Okay, so hi. We have some resources at the TER Lab for security education, and some of them are just, you know, little projects that people can do individually, and some of them are competition kind, so maybe look into that.
Okay, thank you.
Tom Beecher from Yahoo. I echo what Matt said. Very good job already. Also, thank you for that little EEM bit there, because I'm going to have a lot of fun with Matt using that.
All right, thank you very much.
There's actually a few of Ryan's colleagues here. I'll point them out if they don't mind. There's a group of DePaul students right there. Raise your hands real loud. There's one over there somewhere, Joe. Where are you? There you are. So I'm sure some of those folks are looking for jobs. So anyone who's looking for Ryan and those type of folks, they're here. So don't be shy. Next up, Christoph is going to tell us about some RPKI stuff.
So thanks for introducing me. I'm Chris, I'm with DKIX, and I'm going to present some details on how we as an IXP can help you to use RPKI at an IXP, and I also give you some numbers how the situation is in general on the internet. So first, let me give you a proper problem statement, even though we all have experience with our routing system. It works very well. We're very happy with BGP, but also we know that there are prefix hijacks, intended, malintended, and also misconfiguration hijacks. So this situation can be changed, and the security of the entire internet can be changed by adapting new features such as RPKI for doing origin validation. We as an IXP care about the internet and the internet community, so we also want to boost the acceptance and usage of RPKI-based prefix origin validation. And to do this, we really look into what we have today at the IXP already and what we can deliver in the future. So therefore, here we have the standard setup at an IXP. The IXP is the cloud in the middle. We got some custom edge routers, and they are all connected to the IXP's route server. So this is sort of a centralized routing service, such as a route reflector. And if we think of RPKI, each customer has to do it on its own router, right? But the issue might be here, the router is not capable of doing so, or there are other issues with configuring it into it, or like doing a software or firmware firmware update, which is not what you want to do on a daily basis, and especially not for a feature that might be valuable in the future, but not from now on. So given that there is a central instance anyway at the IXP, so why not delegate the prefix validation to the route server? So this is what we propose, and a lot of our customers, especially the small and the medium ones, were asking for, like, could you help us out here? And since the route server is basically not a hardware server with a fixed firmware, it's like running on a commodity server where you can always deploy your Python tools or whatsoever, like your own tool chain to do the validation. The issue now is, okay, we can do the validation at the route server, but this information has to go back to the routers, to our customers. And the issue is how to signal the different states of the validation process, like how to propagate the results to the peers. Fortunately, there is already a solution for IBGP, which uses extended communities for the signaling, but this is, as I said, limited to IBGP. So we just put this together with a eBGP, and in a process we started in the EuroIX community. AMSIX did some great work on implementing RPKI at their route servers, and we got in touch with them and FranceIX, and together we decided to push an internet draft to really standardize the signaling process to make it easy for our customers to use it, and that they also can use it at all IXPs in best case scenario over the world to get the signaling of RPKI validation results. So now let me speak about some numbers. We have a prototypical implementation, and what we see here is like the global stack plot with the global RPKI covered prefixes. So this is a /24 equivalent, and it's the around 900K prefixes account for about 8.3% of the advertised IPv4 space. So this is acceptable number. I mean, we are already at about 10%, but there's really a lot more we can do. So now, as we know how the global situation is, let's focus a bit more on how does it look at the IXP. Especially here we see the different RIRs, and we see that the first left plot shows the distribution of the total IPv4 address space. Like, as we know, ARIN got about 45%, APNIC and RIPE about 20%, and LACNIC and AFRINIC like a lot smaller portion. And then on the next plot, like just on the right, it's this same RIRs again. We see how much of this space is actually advertised globally. And according to this, we see just always below the first plot the percentage on how much of this space is covered currently by RPKI. So we see that actually of the advertised space, it's the bottom right plot, we see that RIPE does a very good job with about 23% of all /24 equivalent prefixes are covered. And we also see that especially ARIN could do a lot more to boost the RPKI stuff here. So if we continue to focus on what do IXPs do and how does the situation looks there, like first, just to give you an idea of how much prefixes you would expect at a route server at the different DKIX IXPs, we see that, for instance, Frankfurt, as the flagship, has about 160,000 prefixes, and New York about 60,000. And below, we see the percentage and also the fraction of valid ones. We see that Dubai, in fact, has a huge coverage, but if we look at the number of total prefixes, like only 700, then we know, okay, this is due to the fact that the total number is so low. But we also see that the numbers in Frankfurt converge to the global numbers, right? So we see 7.3%, which is close to the 8.3 global coverage. But we also see that the smaller ones got a higher coverage, which probably comes from the fact that in the ripe area, the number of valid prefixes is quite high, actually. So to continue with the invalids, we see that, again, Dubai has also a huge number of invalids, and Frankfurt has less than 1% invalids. And this is also what we know, what we see, like if we look at the stats which are on the internet, that the numbers are very low for the invalids. And then the majority of the prefixes, again, is just not found. So go and create a ROAS. It's a very, very easy, especially, I'm just familiar with the RIPE tools. That's fairly easy. It costs you like 10 minutes. And if it might not help you at the moment, it might help you in the future and protects you from hijacks. Or there might be something new up at the horizon as a BGP-SEC, whether it will make it to operation or not. We first need really this basic origin validation to proceed to make the global routing system more reliable. So if we now focus again on the IXP in Frankfurt, then we see that the number of prefixes that are not found is about 90%, and it would account for 86% of the total traffic. The invalids is just 0.5% of the traffic, and the valid is just 12%. So the takeaway here is if we would activate and enforce our PKI validation and would just accept prefixes that are valid, we would just have almost 30% of the total traffic at DKIX Frankfurt. So if we take a closer look at the invalids, we see that the unauthorized ASs that announced account for 65% of the invalids, actually, which would be only a data volume of 8.5%. On the other hand, we know that max length is an issue with RPKI, and 35% of the announced prefixes are too specific, and that's why they're invalid, and that would account for almost 92% of the traffic. So let me conclude. There are really advantages in deploying the RPKI at route service at IXPs. It's really the idea to make it as easy as possible to start with the RPKI stuff and let the validation do someone else on behalf of you. A lot of especially smaller networks were asking us for such a feature, and as a community-driven company, we really take care of what our customers say. We don't necessarily take care who's screaming the loudest, but we're taking care of how many people asking us for things that we should do. And the challenges here are clear. The adoption of the route server features by the peers. I mean, if you get the communities back, you need to react on this. Like, you need to change something in your configurations. And we also need the adoption of RPKI by ASs, so we need you to create ROAS and really use this stuff. And we also got some let me say, issues with the ARINs, relying party agreements, so that we may not use their data to really do the validation. We are working on this and need to get a clear understanding of what's going on there. And our ongoing work for the moment is that we have the internet draft to standardize it under development. As I said, it's an internet draft, and we plan to really deploy this feature at DKIX Frankfurt. So thank you for attention, and I'm happy to take your questions.
Matt Pitak, Yahoo. Quick clarification. Are you saying that you're going to be implementing RPKI-based decisions on routes at the route server, or are you simply doing the validation, making no decisions, but passing communities along for members?
Yes, the latter one. So we're not going to drop any route or anything at the route server. We just provide you the information, what the result of the validation is, and you can decide whether you do something with it or not.
How does the participant validate that the communities affixed to the prefix are indeed being sent from the route server and not by somebody else spoofing the information?
Yeah, so this specific communities need to be filtered at the route server.
Gotcha.
So, right, if you're sending it toward the route server, you're not allowed to do so, so it would be removed. So basically filtering at the route server is the answer.
All right, thank you.
You're welcome.
Hey, Vikas from Microsoft. So the question is, do we have to pair with the route server for this? And second is, will the route server be doing the L3, as in will it inject the AS, or it will be transparent? Because how do we take care of the AS path when it goes, the decision goes through the route server?
Okay, so I didn't understand the second part. The first part, the answer is yes, you need to peer with the route server in order to get this information.
And the communities will be sent from the customer towards the route server, or route server will?
No. The route server does the validation. So the route server will does the validation for each customer, basically, and then send the communities, like add the communities for the prefix and send it to all the other customers.
Okay, right. Thanks.
You're welcome.
Hi, Doug Montgomery. Did you say you're currently using ARIN RPKI data, but might not in the future, or that you're not currently using it and it's under consideration?
We have a prototypic implementation, but we're not sure if we legally allowed to use it for a product. So that's why we don't really have the final product, but we consider it and we're looking into it.
So, hi, I heard your talk yesterday at the RPKI panel, and I seem to remember that there was, you gave some statistics about how many valid, how many invalid, that there were quite a few invalid because of misconfigurations. Could you just say a little bit more? What's the main reason that these misconfigurations happen?
I guess the issue for the misconfiguration is that people are not educated enough. So people don't really understand how this system works. They put like a max length, and then the customers go and announce a more specific. So, and then it's invalid, obviously, since it's not allowed to do it. And I guess really what our community has to do here is really to educate the operators and really help and give out easy tools, very good documentations, because that thing is not rocket science, right? But for people who have to do it as a side job on their daily business, they may not find the time to do it or to really look into it, so we need to make it as easy as possible, and that's what we do by offering such a service, you know, like trying to help where we can.
Thank you.
You're welcome.
Sandy Murphy. Oh, good heavens. Parsons. The standard answer as to how come there's so many invalids are either the max prefix problem, you know, you set it for a max and somebody announces something longer. There's also the case of I say that I'm going to announce my prefixes, forgetting that I've handed off some of the prefixes to a customer and they're announcing it from a distant.
Exactly.
I know of one implementation that at the point of creating a ROA says, and oh, by the way, you are about to make the following routes invalid. And I thought that the RIPE interface also gave you that, that warning. Is that not the case? Or are people ignoring the warning or not using the warning?
So like that might be a new feature. I looked into it like a while ago, so I'm not aware of this warning, but it would make sense. But yeah, we all know how it is with warnings. Yeah, I mean, if we start our notebook and there is a warning, hey, watch, there's X, Y broken, and then you tend to click cancel or okay or agree. I mean, you know, we need to make people aware of things and that they understand what we are telling them.
Right,
So,
right, okay. I just was, yeah, I thought that the warning existed at the RIPE interface.
yeah, okay,
So
sorry.
you don't know that. Okay, thank you.
Matt Petak, Yahoo again. And Sandra, thank you. Very, very good point on that. To couple what you were wrapping up with, you were urging, hey, everybody go out there, even if you're not going to do anything else, create ROAs for your objects. Everybody needs to hop on board with this. But as Sandra was just pointing out, we've got a lot of people who don't really understand. They're putting in incorrect lengths or prefixes move around and they totally forget. Are we perhaps in a situation right now where we are jumping forward, urging people to dive into something, but we haven't really as a community done sufficient work to make sure that we've made a robust implementation of it that's going to prevent us from just creating more and more of a mess? One of the concerns people have, for example, on the route registries today is there's so much crap and cruft in there, you can't really do any meaningful filtering on it anymore. And yeah, I know, I'm going to keep looking at some of it's clean, some of it's not, depends where you look, which registries. But the fact of the matter is, garbage in, garbage out. And are we in a situation where right now not enough people actually understand how RPKI works and the tool sets we have for it are not adequately clear in how they work, warning people about, hey, I think you're about to screw things up, or you've got objects in here that don't seem to reference routes that exist. Are you really sure you're putting the right pieces in? Are we going to end up with more and more invalids showing up because people are putting garbage in the system because they don't understand it? And would it be better for us to get the system more robust first before we populate it with a bunch of garbage and end up with just lots and lots of invalid messages?
Yeah, so I guess it was not a question, it's a rather a statement, and I agree to this statement, and it's sort of educational science question, right? I mean, we could look at any new technology deployed in a field and people are going to have the same trouble. So yes, we need to educate people and really to make it as easy as possible for them to not make mistakes and not blame them for misconfiguring things in the first place, because we should blame ourselves because our tools are not easy enough, right?
Sandy Murphy, Parsons. In the routing registry problem right now, the data itself is bad. I think the word this morning is something that a little lady would not use. So in that case, the data is the problem. The garbage in, garbage out is the data. In our current situation, the data is very highly assured. The people are the, well, not going there. There are tools available that will let you take a look at what the impact would be on your system if you would employ RPKI, so you have an idea of, from your standpoint, what would be the status of the routes that you see. Those things are good incremental steps for when you're going to consider what you're going to be doing. You know, you could look at what your neighbors would see. You could look at your IXP's service. So all of those things, you know, this isn't something new and people aren't used to it yet. We do need the education. I'll mention Workshop in a Box that was mentioned yesterday. There's things available. People should be looking at it, and you should be at least certifying your address space just so you're prepared.
Yes, I agree. You're raising a good point, and I also think it might be valuable for you if you have an ISP with a website. You might just publish what you're seeing. like as we created some statistics now, what we see at DKIC Frankfurt, just to keep people updated how things are growing and how, and at some point they will feel that it gets relevant, and then they will also implement it and start to take care of it. Okay, thank you. Sorry for taking so long, John.
Well, we have one person who couldn't make it, so we do have a little bit more time, and since none of you volunteered to come up here, I had one thing that I thought I would share. I'll torture you with. Hopefully it'll be fairly easy. So some of you may have been familiar with the service that we started at Team Cummery. Some of you may know I recently left Team Cummery. So this is a service whose future is somewhat in question. I don't know what the state of this will be down the road, but I'll tell you a little bit about it and how I left it. This was essentially a community-based remote trigger black hole service. We tried to solicit as many ISPs and networks as we could that had essentially an ASN and some prefixes to announce. If they ever wanted to black hole any addresses or literally an address, we only allowed /32s for V4. We would then relay them on to other networks, so that the idea being that you could relay black hole routes to not just your upstream or up here, but essentially anyone who's plugged into this project. So that's it in a nutshell. So as I left it, there was about 140 networks who were literally active and peering. Presumably, all those networks were, when they received the routes, they would distribute them in their network or not route traffic for them, although I know of at least a couple who were sort of in learning mode, test mode, prototype mode to see if they were going to ultimately trust this system or not. But I know some were actively blocking routes. There was an even larger number of networks who were interested or potentially interested in participating. That number, 150, is conservative. There was probably maybe 200 or 300 people who asked us about participating and had gotten some partway through that process in doing that. That was actually one of the biggest challenges. We have a lot of people who would ask us about doing this, but actually getting them to conclusion to be set up and peered was seemed to be a significant hurdle to actually complete that process. So when I left, there was anywhere between about 5 and 50 announcements that would go through this system in a day. And it's still going on. It usually tends to be more announcements during the week. For some reason, that's just sort of when activity starts to happen. Weekends usually tends to be a little bit slower. Only about a little bit less than half of the networks were actually announcing prefixes. Everybody else was simply just in listening mode, presumably, not having anything to announce for one reason or another. And since we had been running it, I've seen about 9,500 announcements, of which some smaller percentage, about 20% of which were actually unique. And as we left it seemed to actually be working well. I never heard of any real complaint like we relayed a bad route on, or someone had some serious disruption because they couldn't get to some service because of the service. So you can go learn about more details about how this project worked and what it did through that page, which I no longer maintain, but it should still be reasonably useful if you want to take a look at it. I thought it would be helpful now to show you a little bit of a view from how it actually worked behind the scenes. I'll just show you some of the actual code. So here's the database tables that I used. I basically set up a handful of Postgres tables and sequences to maintain this. And really only 3 are the ones I'm really going to show you any detail about. The first one being there was a network table. So this was literally just an ASN name. Not really much magic there. Then we had the peer table. This is where all the peering configurations were basically stored, or some part of the peering configuration would be put. We've enforced MD5 passwords on everybody. Sorry, Patrick, but we wanted those. That was really our only protection because we were multi-hop. You see this last seen field at the very bottom of this table. That would be updated anytime we received a keep alive from a peer. So we could see, just by looking at the table, who is active or not. And then perhaps the most important table is this routes table. So anytime anyone announced a legitimate and valid route, we'd essentially put it in here. And we'd put some detail about, something about it, like when it was announced. And of course, the associated AS and the path and so forth. And if it was withdrawn, then we'd set it to that field withdrawn to be true. So it's very simple. So our first presenter had this, a system not unlike this, but much more elaborate. That I don't know what their database and code looks like, but I'm almost certain that the stuff that I had here is much smaller and simpler, probably much less feature-rich, of course. The way that this worked is we would get a route, we would use ExaBGP, we would get a route, and in ExaBGP we would take that announcement and we literally just dump it off into syslog. And it's quite easy to do that. You can the way I did it was I had Perl script, that's what I know, that would receive this announcement. It would do some basic validity checks and then pass it on to syslog. It would do that for both received updates and for keep alive messages. Those are the two things I cared about most. I didn't really care about notifications or anything like that. You know, if the session went down, oh well, you know, I would just keep track of things via keep alives. And then on the I use syslog ng. On the syslog side, here's where we would then track the actual announcement. So I tried to separate the route process with ExaBGP from the handling of the routes, what we did with them once we received. I didn't want to put too much burden in ExaBGP and create any issues there. So I basically punted off any announcement that we got very quickly into syslog and then handled them in a separate process there. So syslog ng has a capability to run a daemon and watch for specific logs. So that's what I had another pair of scripts here that would be a little bit more elaborate, especially for the updates piece. The updates piece would literally look at the announcement that it got from syslog and then do all of the verification on that announcement and the peer who sent it. So that's where all the magic happened, and I'll show you a little bit about, I'll show you essentially some pseudocode, the next slide of what that does. But that's pretty much it. The actual control pieces were relatively simple, relatively small, made it kind of simple, and perhaps that's what made it fairly reliable, robust, and reasonably safe, at least as far as I can tell. So the updates piece is, I don't know how well you can see that, it seems to be large enough font. I'll go through this sort of step by step to give you an idea of what we did. So when we received a route, first thing we did was make sure it was an IPv4 route. So we're looking for an IPv4 address and it's a /32. That's what that first next statement is. If it's not that, we're going to skip it. We're just going to ignore it. We're going to move on. Next thing we do is make sure this is a valid peer. If somehow some message was to get into syslog that wasn't an actual peer session that we had established, then we're just going to skip by that as well. The next thing we do is make sure that the route that we've gotten is not something that's obviously bogus. So we essentially have a bogons list in memory, and that's all the obvious stuff like the RFC 1918 addresses and so forth. So if that exists, then we skip by that. And then we see if it's either an announcement or withdrawal. So it's one of those two things. If it's an announcement, then we want to do some additional checks to see if it's something that we can relay. So first we check the historicity of this prefix, the /32. This is the key piece to doing the validation. So we don't do RPKI or any of that sort of stuff. We just look at the route history. And RIPE has this awesome interface to their data called RIPEstat. It's an API that's a RESTful interface. You can basically give it an address and a time frame and say, tell me about the history of the covering prefix. And so given this /32, we ask RIPE about it. And if RIPE comes back and says, for this /32, I've seen it announced by this ASN and for this period of time, and it matches what we have configured for the peer, then we assume this is valid. And the person or the peer who sent us this route, it's legitimate and we can relay it on. So we literally just verifying that there's a history of this route that exists that's solely originated by the ASN that we're peered with. If you have the multiple origin AS issue, then it's actually not going to work. We're not going to relay it. So we don't solve that problem. We've thought about how we might solve it. We can solve it manually. If someone was under some duress, we could inject a route manually, but we didn't actually overcome that programmatically. And then if there's some other couple of checks here, if it's for some reason we have a manual blacklist that we'd, for instance, if Google was a peer and they might have said, you know what, make sure you never black hole 8.8.8.8, for instance, that might be in a blacklist. And then we also have sort of like a max prefix check. We didn't want peers to announce essentially, /0 worth of address space, right? So if a peer had already been announced to us more than, or had announced to us 25/32s, then we're not going to accept anymore. That was sort of just an arbitrary limit. We had some people who asked us about maybe increasing that to like 200, 300, 400, or 500, and that's potentially feasible, but that was just a sort of a built-in safety net. If it was withdrawal, that's a little easier. We just have to check to see if we already announced it. If we already announced it, then, and that looks valid, it came from the peer who announced it, then yeah, we'll just withdraw it. We'll relay that withdrawal on to everybody. And then we update our database. We send out an update out of band. We have a separate mailing list that literally, if not many people subscribe to it, but if you wanted to see updates in real time, that would go to a mailing list. And that was essentially that. That's all the secret sauce that we had. So having done all that, the system itself, I thought, worked reasonably well, using a very well-known technique, the destination-based remote triggered black hole. Those who used it seemed to be reasonably happy with it. We had a handful of people who would never use it, and there's probably two of those people in this room for one reason or another, mainly about trust, which I get, I understand. And we had a few people who needed help literally getting set up. We had to really help them configure their routers to be able to both do the announcements and to receive them. A lot of people hadn't done this before, which sometimes was surprising, but for smaller networks, maybe not so much. I had a number of people who would send us their full routing table, which was not wanted. It was not helpful for me at all. That would just slow our code down to have to look through that. So we occasionally had to tell people, please don't do that. The other thing there's a couple things we didn't get around to doing. Some people wanted us to do flow spec. Not many people, perhaps enough that was a curiosity that was on the drawing board, but somewhat a low priority. If I had to count, it would probably be about a dozen, maybe 15 people who were interested in doing flow spec. We had tried to do a project like this with flow spec a few years earlier, and we literally got no interest. So that's some progress, I suppose, if you're interested in flow spec. It would have been nice to have a little bit better interface. This is all done via BGP, but there's no web interface to like reconfigure your peer or anything. It's essentially an email to me. And lastly, literally, I don't know the state where this project is going to be going forward. I left it, and there was no one person who was essentially responsible for it. So who's going to be taking over programming of it. So any of you who are using this, I think you're still safe. The code, I think, is very robust and reliable, but I don't know what the future of this is going to be. It could run forever as long as RipeStat still works, but I don't know if Team Cymru is going to carry this forward. And I'm curious, maybe the question I'll pose to you in closing is this something that ought to be continued? And if not by Team Cymru, perhaps from a project like we had from our first presenter in that forum, or something like it, should we go about trying to build this sort of thing? It's not easy to do, not only from a technical perspective, but to get people to use this stuff is incredibly difficult. And so I wouldn't want to redo this if people aren't going to come back and go through a version 2 again. I got other stuff I could be doing as well. So I'll leave you with that. If you have any questions for me about it, I'm happy to field them. But it's also, we have enough time for questions about any of the other presenters. I'm sure they'd be willing to come up and go into any further detail. Or, since we have about 15 minutes, if there's a pressing question that's come up recently that you want to pose unrelated to anything you've heard so far, but something to do with network security, then now's your opportunity to do that. So with that, I thank you for your attention. And if there are none, I'm sure everyone will be happy to go to lunch. But it looks like we have at least one person who will jump up and... Matt?
I don't think I've let a speaker go by without asking a question. Woohoo! So Sense versus this project, it seems like there's a fair amount of overlap between you and our first speaker. And if you're looking for ownership or where to park this kind of an effort, is this something that could be integrated with it, or is it something where we would look at it as a community and say, well, forget just black holing it, let's actually do smarter filter-based traffic blocking the way Sense is looking to do for people? If your big challenge was trust, it seems like it's going to be the same trust challenge, whether it's Sense pitching, filtering the routes, or you pitching black holing the routes. So I'd say that seems like a really good place to park it if you're looking for an owner.
Yeah, I agree with you. I don't know that I can answer on behalf of everybody, but I didn't know about this project until just about a week ago, so I think we probably would collaborate and share some knowledge about this sort of thing. The problem is inertia, but that's not with just this project, it's RPKI and DNSSEC and other stuff like it, so that's just always going to be a problem, right? Never underestimate the installed base is what I tell my students, right? So, yeah, I mean, I'm happy to let someone else do most of the work. I'll happily I can't give you necessarily what Team Cumry has, but I can certainly help re-implement something if there's anything I could do in that regard. Well, seeing no one else at the mic, I declare the session over. Thank you very much for your attention. Let's all go enjoy lunch. And thanks to Jeff and the people in the back room for all the support. It was very helpful. Thank you.